So one of the things that we're going to look at next is some applications involving the normal distribution and some different things that involve the percentages that we spoke of before about the percentage of data that falls under the normal curve within one standard deviation, two standard deviations, and three standard deviations and beyond from the mean. So in terms of how you want to solve a normal distribution problem, I want to sort of speak to this whole business of the four-step process. So remember, the four-step process is state, plan, do, conclude, and that's typically how you want to answer a free response type question that involves the normal distribution. So what you want to do in order to do that in the state part is you want to express the problem in terms of what it is that you're trying to figure out. That's the state part. The plan part, you want to draw a picture of the distribution. So you want to draw your normal curve and shade in the part under the normal curve that you're looking to sort of figure out. The do part, okay, you want to standardize the value of x, meaning you want to compute what the z-score is for the given value or values in the problem, and then you want to use your normal CDF and your calculator in order to answer those kind of questions. And then once you get your area under the normal curve, you want to state your conclusion within the context of the question. So that's just kind of revisiting some things with state, plan, do, conclude in regards to how you want to answer a problem like that with the normal distribution. So here's an example, and the question says, on the driving range, Tiger Woods practices his swings with a particular club by hitting many, many balls. When Tiger hits his driver, the distance the ball travels follows a normal distribution with a mean of 304 yards and a standard deviation of 8 yards. And so the question says, what percent of Tiger's drives travel at least 290 yards? So what we want to do first here is we want to draw a normal curve. So let me kind of back this up a little bit here. So here's my normal curve. And here's the 304 down the middle. So at least 290, I'm kind of going backwards from the mean here. So if I go one standard deviation from the mean, this is going to be 296. And if I go another standard deviation from the mean, this is going to be 288. So let's just approximate maybe 290 is like right here. So what I want to know is what's the area under the normal curve that sort of encompasses that right there. So you guys can clearly see it's going to be more than 50% of the time this is going to occur. So in terms of my do part for this, okay, I want to know first, what's the z-score for 290 yards? So to find the z-score, I'm going to take the data value minus the mean divided by the standard deviation, and I get negative 1.75. So then from here, I want to do the normal CDF from negative 1.75 to positive infinity. And when I do that, this is the value I get, 0.9599, which basically means that approximately 96% of the time, according to this data, he's going to hit his drive at least 290 yards. So that's just one type of application question involving the normal distribution. Here's another one. And the question says, when Tiger Woods hits his driver, the distance the ball travels can be described by a normal distribution. Once again, so I'm just abbreviating this here. Normal distribution with a mean of 304 and a standard deviation of 8. And then the question says, what percent of his drives go between 305 and 325 yards? So once again, I'm going to draw my normal curve first. Right here is 304 down the middle. So 305 might be like, like right about here. And then if I draw just one standard deviation from the mean, this is going to be 312. A second standard deviation from the mean would be 320. And then a third standard deviation would be 328. So 325 might be, I don't know, maybe right about here. So I want to know what's the area under the normal curve. That's basically this right here. So once again, I got to find the z-scores, but now I have to find the z-scores for both 305 and 325. So when I do that, And here's sort of a better picture, I think, of that there. So when I do that, here's the z-score for 305. So I'm going to do 305 minus the mean divided by the standard deviation. So that's the z-score for 305. And then I want to do the z-score for 325. So that'll be 325 minus 304 divided by 8. And when I do that, I get 2.625. So what I want to know is, what's the normal CDF from 0.125 to 2.625? And when I do that, I get 0.4459, which means, conclusion-wise, that about 45% of his drives are going to travel between 305 and 325 yards. So once again, just some application type things here. Here's another one, okay, a little bit different. And the question says, high levels of cholesterol in the blood increase the risk of heart disease. For 14-year-old boys, the distribution of blood cholesterol is approximately normal, with a mean of 170 milligrams of cholesterol per deciliter of blood, when a standard deviation of 30 milligrams per deciliter of blood. And the question says, what is the first quartile of the distribution of blood cholesterol? So a couple different things you got to do here. So remember, first quartile, this is the 25th percentile. So as far as what I want to do to work this out, first thing I want to know is, what's the z-score for 0.25? So I know what the percentage is here because it's giving me the first quartile. So this is what the z-score is for that particular percentage under area under the normal curve, negative 0.6745. So I got to know that first, and now that I know that, I can use the formula for a z-score, right? So just kind of put this up here. Remember, z is the data value minus the mean divided by the standard deviation. So I'm going to put this in for z. I'm going to put this value in for the mean. I'm going to put this value in for the standard deviation. And when I get that, here's what I got. And then I'm just going to take this and I'm going to solve it for x. And when I do that, I get this right here, 149.675. So using the same data as we did from the previous question, why don't you take a moment and see what you could do with these questions on your own. So with question number 1, you have cholesterol levels above 240 milligrams per deciliter may require medical attention. What percent of 14-year-old boys have more than 240 milligrams per deciliter of blood? So what I first want to know is, what's the z-score there? So if I draw my normal curve, and here's 170 down the middle, here's one standard deviation, that's 200. This would be 230, two standard deviations, so I don't know, maybe 240 is right about here. So I want to know kind of what the area under the normal curve is there, kind of small. So here's the z-score for that data value. Now I just want to know, what's the normal CDF from 2.33 to positive infinity, which comes out to be about 0.0099, which means roughly about 1%, this is what that's going to round to, of 14-year-old boys have more than 240 milligrams per deciliter of cholesterol in their blood. Question number 2, it says people with cholesterol levels between 200 and 240 milligrams per deciliter are at considerable risk for heart disease. What percent of 14-year-old boys have blood cholesterol between 200 and 240 milligrams per deciliter? So if I go back to my normal curve again, here's 170 down the middle. Here's 200, here's 230, so I don't know, maybe 240 might be like right about here. So I want to know, what's the area under the normal curve that's between these values here. So once again, I got to compute z-scores. So the z-score for 200 is going to be 1, and the z-score for 240 is going to be 2.33. So what I want to do from here is find what's the normal CDF between those two values, between 1 and 2.33. So that's going to be approximately 0.1488, which tells me that about 15% of 14-year-old boys have between 200 and 240 milligrams per deciliter of cholesterol in their blood. And then finally, going back to the Tiger Woods question that we did from the first example, it says, what distance would a ball have to travel to be at the 80th percentile of his drive? So remember, here's the normal curve, and maybe 80% of the data falls here. So what I want to know here is what's the z-score here, and then from that I can figure out what the value of x is. So to do that, I'm going to do the inverse norm of 0.8, and that's the z-score for this value right here. Then I can use that in the formula for a z-score to figure out what the value of x is. So I'm going to put the z-score in here. Here's the mean, here's the standard deviation, and when I do that I get 310.72, which means that about the ball would travel 310.72 yards, would be at the 80th percentile, meaning 80% of his drives are less than 310.72 yards there. So that's just some different things involving the normal distribution with some calculations and things like that. So last thing to look at, or at least we're going to look at this point with normal distribution, is how do you know when you have a data set, how do you know if the data is normal? So we've talked about how normal kind of aligns itself with graphs that are roughly symmetric, and one of the things that you can commonly do with that is make what's called a histogram, and you can check your histogram to see that your shape is roughly symmetric. But there's also something that you can do that's a little bit better than that, and it's what's called a normal probability plot. So one of the things when we're talking about assessing normality, big thing here, plot your data. Okay, whether it's a dot plot, stem plot, histogram, I'm going to show you a normal probability plot here in a minute. Because if your data is not normal, if your data isn't roughly symmetric, then all of these percentages that we talked about do not apply to graphs that have any type of skewness, skewed left or skewed right. These percentages here, only apply to normal distributions. So it's very important that you plot your data and you know what type of shape you're talking about in regards to the normal probability type percentages. So the thing with the normal probability plot, and I'm going to show you guys how to make this on your calculator. What you're basically looking for in a normal probability plot is you're going to take your data and you're going to plot. I'm going to put your data in L1, you're going to make a normal probability plot, and if the points that you plot come up to be roughly linear, then we would say that that particular data set is normal. So so you have here at the end outliers appear as points that are far away from the overall pattern of plotting. You'll see that when we kind of make one of these here. So here's an example of a histogram. You guys can see here some strong skewness to the right. This is what the normal probability plot looks like. So what you're basically doing when you make a normal probability plot is you're plotting your data value along the x-axis and you're plotting your z-score for each of those corresponding data values on the y-axis. So in terms of following through with one of these questions here, so the question here says the following data shows the unemployment rates in the 50 states in November of 2009. Is the data normally distributed? So here's what we're going to do. Okay, we're going to kind of bring our calculators up here to answer this question. So I'm going to go to Stat, I'm going to go to Edit, and let me go to L1 here. And I'm going to clear out this here. And I'm going to put the data values in for this particular question. So I have here, just putting these in, 4.1, 6.7, 8, 9.1, 10.6, 4.5, 6.9, 8.2, 9.2, 10.8, 5, 7, 8.2, 9.5, 10.9, 6.3, 7, 8.4, 9.6, 11.1, 6.3, 7.2, 8.5, 9.6, 11.5, 6.4, 7.4, 8.5, 9.7, 12.3, 6.4, 7.4, 8.6, 10.2, 12.3, 6.6, 7.4, 8.7, 10.3, 12.3, 6.7, 7.8, 8.8, 10.5, 12.7, 6.7, 8, 8.9, 10.6, and 14.7. Doesn't matter which order you put those numbers in. So in order to make the normal probability plot, once I put these numbers in, I'm going to go to second y equals, go to plot 1, and turn your plots on. And then the type of graph that we want is this graph at the very end here. Okay, this is what the normal probability plot is. So then go to my list. I put my numbers in L1, so I'm going to put second one for L1. Okay, and then if you zoom stat, which is zoom 9, here's the normal probability plot. So I think you guys can see here, you get a graph where the points appear to be roughly linear. So because these points appear to be roughly linear, what that means is this data set here, is the data normally distributed? Yes, it is. Okay, and it's normally distributed because the normal probability plot, I'm just going to abbreviate this, is roughly linear. So just remember the whole significance of knowing whether your data is normal or not. The significance of that is if your data is not normal, then all those percentages that we've talked about, the standard normal table, does not apply to anything other than data that is normal. So just some summary things here, some things with the normal distribution, some things with the empirical rule, and some other things involving the standard normal distribution, the normal CDF, and some things like that with your calculators there.